First of all, thank you for attending today's RDA webinar on Data Description Registry Interoperability. My name is Katrin Beck. I'm from the RDA Europe Training Program team. First of all, I would like to present you our speakers. We have Dr. Amir Aryani. He is co-chair of DDRI working group and the project lead for the Research Data Switchboard. He is working in the capacity of a project manager for the Australian National University. His research interests include network analysis and creating the research graph that connects research information across data infrastructures. Dr. Jingbo Wang has a PhD in geophysics from the University of Cambridge. She then worked at the Lawrence Livermore National Lab in US and Geoscience Australia. She joined the National Computational Infrastructure (NCI) in 2014 as a data collections manager, where she is leading the migration of data collections onto the RDS, the Research Data Service, funded file systems. Jingbo focuses on building the infrastructure to support data management, data policy, data citation, data ingest, and publishing logistics. Amir, would you like to start our webinar?
Okay, thanks, Catherine. Thanks for the introduction. Hello, everyone. My name is Amir Aryani, and as Catherine mentioned, I work for the Australian National Data Service. I'm also the co-chair of the DDRI working group in RDA. Now, in this webinar, we are going to have the two different speakers and two different topics. So, in the beginning, I'll talk about the DDRI working group and the background, what we have done during the operation of the working group, and one of the outcomes of the working group, which is the research data switchboard implementation, that one has been adopted by NCI, and Dr. Jingbo Wang is going to talk about that infrastructure in NCI. Now, there are a number of graph visualization in this presentation, which I was thinking what is the most efficient way of doing that to basically bring those visualization live. Given this is a fixed PDF presentation, that cannot be done easily. However, I am posting the link to this presentation in the chat room. You, at any stage on any of these slides, you can actually follow the same thing on the Google Doc, and there are links on those slides that take you to the graph visualization on the website. So, moving forward, this is a very early slide that we use in the at the initial point when we were working on the idea of interoperability platform between different data infrastructures. This is really even pre-RDA working group. That was a time that in the Research Data Australia, we had a function, and that function was trying to find the other data sets that can be linked to the particular collections on the page. So in this example, we have a collection from the Research Data Australia, and that highlight that goes to that box, it actually shows the number of links that we have discovered in DataCite and other external resources. Now, the problem is that the number of recommendations are about 13,000 records from matching subjects and more than 1,000 records from DataCite. So from perspective of recommending the other related data sets to this collection is not particularly useful. Now, this was a problem we initially had with a number of partners that are contributing records to Research Data Australia, but also talking to other data registries and repositories like Dryad and CERN, we discovered that, okay, this is a problem across all of these infrastructures. So this was the initial hook point that we got all of us together to thinking about this problem. Now, about 18 months later, we kind of got the working group, that the working group has produced some recommendations. So given the scope of this presentation, I'm not going to actually talk about all of the steps that we did, but really I want to actually get to the final results, that after testing different models, we came up with a practical approach that we can actually link data sets using the co-authorship and the other form of collaboration model like joint funding grants and joint funding research activities. So during the course of this working group, we had the chance to work with different partners, and was one of the initial funding members of the working group. Then we had a Dryad and CERN from those early days, and also later on we got the active members from Europe, including DataCite, OpenAir, and DARA. And now at the Australian level institutions, we have the NCI and University of Sydney, who are quite active on this platform. So if I want to basically demonstrate that how this actually works, or how we actually connect datasets across different registries, this is one example that if I was a librarian, I could actually look at this and then say, okay, well, this is what I can follow. This is the research data collection on Research Data Australia, and I can see that there is a researcher connected to this. So the researcher is defined as Associate Professor Catherine Biaf, and if I search this person on the web, I will find that researcher in the University of Sydney website. Now, going to that page, I would find the information about the research area of the researcher and the publication that the researcher has, including 105 journal articles. So technically speaking, someone can actually go to all of these 105 articles and then read the content of every single one of them. And in one of them, which is published in PLOS ONE journal, you will find a link to the data set from Dryad. So we go to that page into the Dryad, and we see, okay, well, there is another data set by the same author. So here, in this context, basically, we have connected a data set from ANTS to a page or a researcher information in University of Sydney, to the journal article in PLOS ONE, and then to a data set in Dryad. So this process is literally what we have done in early days manually when we were working on the prototype. So we tried a number of these cases to be sure that this is working. And as a result of that, we discovered a number of other things that could be connected, like the joint funded grants, which I mentioned before. Now, the outcome of this in those early days was all aggregated to a graph database. And from that, we came up with the early prototypes. But the point here is that the point on that platform was we discovered that there is a concept of the degree of separation that actually connects records to some level of accuracy. So these are some of those examples. You can have a data set which is linked to a researcher. The researcher can be the author of the publication, and the publication is actually linked to another data set. We can have a data set which is actually cited in a publication. That publication also acknowledges a grant, and that grant have actually another data set linked to it. We can have a data set which is actually, again, cited in a publication. Publication has an author, and the author has another data set. So these are only 5 examples, but we can have a multiple of these scenarios that makes the connection happen by 3 degrees of separation. The point of these connectivities is that the more you increase the number of these separations, the more you actually get the informations into your cluster of graphs, and as a result of this, you have a more coverage, but in some cases you will get some false positives, which means you will get a data sets which are not exactly in the same domain. So moving forward, this was everything that we did manually, but then we came up with this idea of the switchboard. So the switchboard metaphor was coming back to the concept of basically making this connectivity between different boards, when it was exactly the same concept as it was in the telecom companies, and later on it was automated. So based on that concept, we started building the infrastructure on the Amazon cloud that makes this whole process independent from the manual and labor-intensive linking process. So this is an abstract presentation of the research data switchboard on the Amazon cloud, and that's really, well, from the architectural point of view, these are literally referring to different source code buckets and different functions that are running, but also it shows a different layer of computation that we are actually developing for different purposes. So in this context, we have the layer that called data providers, which are a set of harvesting instances. And what they do, they basically read the information from our partners and collect them into the S3 bucket, which is a storage bucket in Amazon Cloud. That information will be passed to the graph creation layer, which in that layer we are doing a number of things, including resolving the identifiers, using the cross-ref integration, data side integration, ORCID integration. We are using the Google Search API, which basically enables finding a paper on other websites in the scholarly domain when it is not in our initial graph database. And we are also we are operating a concept that called linking identifiers. Basically, the concept is that if there is a DOI mentioned in two different nodes, we create a link between them that we label that as a possible connection, and later on in the other phases we are actually merging these nodes together. So once we have done this graph creation layer, we will have a kind of mega graph that includes all the possible connections that we have discovered. When we look at that mega graph, it's not particularly useful because you will have a lot of duplicated informations from different sources. A data set can be mentioned in 2 or 3 different registries. A person can have a ORCID ID, can have a page on the internet, can have actually a record in one of the repositories as a party record. These informations in a process that we call this metadata harmonizations, we basically merge to a more coherent graph, which is much easier to use. For the last stage, which basically includes this metadata harmonization, we use a research graph model, which is basically a simplified graph structure data modeling, which is highly focused on making the relationships between nodes and less tailored toward having a multiple fields. Basically, this is not going to replace the information from the original sources. It's only designed to actually capture all the possible connections. So if I go to the next slide, actually we can look at this model. It is a very simplified model. Like for a grant, we only have a title, a persistent URL, a list of participants, and the year that is started and end. That is the information that we use for disambiguation. For a researcher, we only have the first name, last name, full name, ORCID, and a Scopus author ID. So as you can see, this is not replacing the original metadata record. And always there is a link back to the original record. So if you want to get the full metadata for a node, you can go back to that. Now, the information that I explained, those multiple layers and the graph structure, all of them available on the GitHub under these main repositories. So we have the harvester layer repository, inference repository, which basically matched to our graph creation layer. We have a Neo4j browser, which is a graph database exploration unit, which is basically enable exploring through that graph database. And then we have a web widget, which is the next widget, which is in this presentation I'm going to use to show you some of these connections. So moving forward on this, back to our problem statement. We had a data record from Professor Catherine Beloff in Research Data Australia. So for some of you who have already got that Google presentation on your desktop, you can click on the link on top and it will take you to the page in the Research Data Australia. If you do that, in the bottom of the page, there is a link that says Registry View, and that would give you this information that I'm presenting on this slide. Basically, in the metadata that comes from this data collection, we can see the link to the another data set from University of Sydney. We can see the link to the other researchers, well, there are 2 contributors to this collection, which is Dr. Emily Wang and Associate Professor Catherine Beloff. Then we have a link to the organization, which is University of Sydney, and then we have also activity record, which in this case is a Center of Excellence record that's being contributed through the ARC, which is Australian Research Council. Now, This would be, if you like, I would call it a small graph that tells the story of everything that is connected to this particular collection. And this is what ANS knows or knew about this collection before using the switchboard. That was a depth of information about this data set. Now, when we go to the next slide, and again, you can actually click on that live demo if you're on that slide, and it will take you to the page. You will see in the website that would come to you, there is a widget that this is a screenshot from that. And that shows a graph visualization of all the connections that have been discovered by the research data switchboard. So in the left side, you can see the connection between the original data set, which is highlighted by bright red, which is connected to 2 researchers, and then it's connected to another data set. Now, in the right side, you can see a cluster of blue circles, and all of them are publications. And all of that information came from the information harvested from University of Sydney page about the researcher. That came from the Google search engine. And they are also linked to other data sets. So the process of the switchboard here basically enable ANS to find more connections related to that original data set. First of all, if you look at the left side of the graph, we can see that now we know exactly the structure of connections that takes that data set to other elements in the universe of ANS, basically ANS system. And in the right side, now we have a lots of other information that now can be linked to that original data set. Now, there is one thing I have been asked a number of times, that the interpretation of these links. In this kind of graph visualization or this kind of graph exploration, we do not draw the conclusion of the causality. We don't say that, oh, that grant or that publication directly is related to this data set. We cannot say that. But what we can say is that all of these elements are in the same conceptual domain. So the possibility of someone who is looking at this data set be interested in all of those publications and data sets connected to that is much, much stronger than just doing a random keyword search on the Google for finding the other things with the same keywords on that. Now, I'm going to show another example here when we actually get the information from ORCID. So this is another data set from the Western Sydney University. And again, there's a link on the bottom of the page that you can actually click on that and takes you to the actual page in the visualizer graph. In this example, we can see that there is a data set, but that data set is connected to 2 big clusters on the right. So what happened here is that for the researchers that they were connected to that data set, we had the ORCID ID. And because the switchboard engine actually resolved the ORCID ID from the ORCID APIs to all the connected information to that person, then now we get all the publications connected to that. So the information about this, everything that comes out of this are also accessible to the RESTful API. So if you have a system on the back end that actually wants to digest this information and use it in different format, it all can be done. Basically, this widget is a graphical presentation of what is available through the JSON format and the RESTful API that are the main output unit of the research data switchboard. Now, before I talk about how to get involved, just in case that you have missed the links to the previous slide, what I'm going to do is that on those cases, I will post the link into the chat box. So that make it easy to navigate to those pages. So that was the first link that I mentioned. And this is the second link. Now, if you're interested to get involved in this project, so there is a source code for this platform available on the GitHub. Basically, everything that we are doing is on the GitHub. It's kind of like a main homepage for this. There's a project homepage which is kind of like a landing page which provides similar information of what I mentioned in this webinar. And then we have the DDRI working group. I think that is the main point of contact. This is where we host the conversation and have meetings, and also we have the RDA plenary breakout sessions information available on this page. So this is, I believe, is my last slide. Beyond this, it goes to the Jingbo presentation on the NCI adoption of this technology. I believe we are actually have the questions and discussions at the end. So I will probably stop talking here and hand the presentation back to Catherine.
Would you like to start your presentation?
Right. So, yep, I will start. This is Jingbo Wang, the data collection manager of NCI. So NCI represents National Computational Infrastructure, which is one of the largest supercomputer centers located at the Australian National University campus. As you can see here in this slide, NCI basically managing about 10 petabyte research data, and our data collection covers almost all the Earth and environmental related topics, such as satellite images, remote sensing, climate, weather model, Earth and marine observation, geoscience, water management, astronomy and social sciences, and biosciences. As we know, our data volume has been increasing over the time among the research community. Access to the data and the analysis of long-term data archive become increasingly challenging. Therefore, we need a solution that will not only enable the community to manage their own data assets, but at the same time facilitate seamless integration of these datasets with data from other communities to empower the next generation of high-resolution, data-intensive interdisciplinary research. That's why our data collection is co-located with our HPC facility. So my next slide is this busy figure demonstrates the solution at NCI. So that is to build the National Environmental Research Data Interoperability Platform. In short, we call it NERDIP. With this platform, we will enable seamless high-performance access to national significant data collections using the new data-intensive capacities to support cutting-edge research method. So one critical step to build the NERDIP platform is the integrated catalog system. NCI's catalog system is designed in a hierarchical way. As you can see here, on the top level, that is our summary collection catalog registry. And the bottom is the granular level, which store each individual project node. NCI use GeoNetwork as the catalog display interface. Some of the nodes harvest from the data provider. Other nodes are created by the data provider directly within the node. The two-level catalog are linked using the parent identifier field in ISO 1915. So far, this is what NCI has been managing. And once we have our catalog available, as a user, we may ask questions. For example, on the left-hand side in this slide, what is the usage of NCI's research data collections? And what is the awareness of the available datasets within the research community? Because even though we publish the data, the research community may not know that there are datasets available for open access from NCI. Other questions like, if I would like to know more about this dataset, who should I contact? Or what is the previous research has been done using this dataset? And we find out the RD switchboard can almost answer those questions very clearly by just using some simple queries. So we can query like how many datasets published at NCI are being referenced in the research journal article, how many research institutes are connected to datasets, finding connections between NCI dataset and international repository such as CERN and ORCID, the data discovery. In practice, we ingest all our database from different GeoNetwork nodes into this RD switchboard graphical database. Then we can do the query. So this is a screenshot to show the current status of NCI's metadata database. As you can see here, there are a couple of disconnected groups, but our ultimate goal is to make linkage among those researchers, datasets, and institutes. So it means there are some work for us to do to make more linkage among them. So far, we have identified a couple of benefits that will help us to build a better metadata database in terms of the quality and missing information. For example, the RD switchboard can help us identify the missing critical metadata entries. It also identifies some errors in the catalog entries. It provides analytical view of how research data has been used so far. It evaluates the impact of the dataset, researchers, and institutes. It also motivated us that every single dataset should have an identifier such as DOI, and each researcher is strongly recommended to have an ORCID. So once we improve the quality and connections of our metadata database, we can start asking some more interesting questions by the researchers. For example, which dataset has a high level of utilization and which dataset is underutilized? A scenario question would be like, there are two researchers are doing something similar research using one dataset, but published in two different papers. Maybe they are addressing two different aspects of the same problem or the similar problem using the same dataset. In a more common scenario, reality will be two different groups of the researcher are using a number of similar datasets, for example, reanalysis dataset, and they do similar research but addressing different kind of problem. Now the question is, do they have any conflict of interest, or can they possibly collaborate if they don't know each other? They probably will find out at the conference or they publish in the paper. So when people search the literature, they find, that group is doing something similar to me. But if we made these connections available in RD switchboard, we probably can show the connections of the researcher and the data well before the data has been published in a journal article. So that is the potential for the research community to benefit. And so this is still being investigated. And hopefully at the end of our project, we can have an interesting real story to demonstrate. So finally, we found out this RD switchboard is a great tool to create linkage among researchers, datasets, and publications. The graphical view is eye-catching and straightforward to understand the complex inner connections within the research community. It also demonstrates that data management is a joint effort by the whole research and librarian community. So finally, I would like to thank Amir for us adopting RD switchboard, and I would like to make advertisement for this tool. It's really useful as we use it. So thank you for your attention. That's the end of.
Thank you to Amir and Jingbo for your interesting talk. Do you have any questions?